About roughly.
Oh, about roughly-ish. Yeah, ish. I mean, and there's a margin of error on that, which I don't know what it is. I never. You want to confuse a medical practitioner? Ask for a margin of error on a test. What's the false positive rate? And it's a shame. It's a shame because those are so important. Those are so important. So you guys, when you become nurses, you're all about it. You know what's going on. You need to know that. You gotta know that stuff. Somebody just tested positive for breast cancer. How worried should they be? How worried should they be? That's the kind of question you have to, sit with these people and talk to. The doctor's useless. You'll see why in Project 4. A survey was done. Doctors can't interpret false positives. You guys can though, or you will be able to by the end of this course. All right, so let's shut this bad boy down. And what I want to do, cut that. Don't need this right now. Put the screen up. I want to just give an overview. We'll go for a couple. I won't keep you the whole time today because I don't want to get too far into this. I don't want to actually start crunching numbers today. I want to collect some data today, and we'll crunch it. I will crunch it after you won't need the entire class time on Wednesday to do the in-class part of your exam. It goes pretty quickly. So we'll crunch the numbers next time after you guys are all done your exam. So I want to talk about this. These measures of relative position. And this will be a little bit on the lecture-y side right now. And I say lecture-y in that it's kind of like here's what this is, here's what this is, here's what this is. So we just looked at maxes, 80th percentile, 85th percentile, and so forth and so on. So the big one are percentiles. And essentially, what percentiles are they're just markers. They're markers that subdivide up a data set into 100 pieces. 0 to 1, 1 to 2, 2 to 3, 3 to 4, and you fall somewhere in there. Whatever you're measuring, whether it's height, weight, IQ, you fall somewhere into those categories. There are special ones that are used very often. So some of the ones that aren't used very often, we'll just verbalize, talk about that. They use deciles, and sometimes they use quintiles, and sometimes they use octals, and there's all kinds of different things. But the one that gets used the most are called quartiles, okay? So quartiles, what I want to do is talk about that a little bit today. Quartiles are essentially percentiles, but instead of breaking them up in little tiny subsets of 100, 0 through 1, 1 to 2, 2 to 3, 3, they break them up in quarters, 0 through 25, 25 through 50, 50 through 75, and 75 through 100. And as such, it's much less uber recursive, looking at the entire data set in little tiny pieces, and it's much more kind of, let's look at a much larger picture of the data set. Now, of course, by doing that, you lose some precision. Just like with center and spread, when we look at data grouped into a distribution versus looking at data loosely, you sacrifice a little bit of precision. But the law of large numbers generally kicks in, and you deal with that. With one exception, the exception we'll deal with next time as well. So, quartiles, there are 3 of them. Let's get it very nice. Very, very nice. Let's test this motion sensor theory out. I like this.
Oh yeah.
Maybe they have them in the lights. It's worth an experiment. What did I just do? I just have to hold it in. There we go. Okay. So there are 3 quartiles. There are 99 percentiles, which seems kind of weird. Actually, I shouldn't say that. I take that back. There are 99 integer percentiles. P1, P2, P3, P4. And I'll put those, we can kind of make a little laundry list, like P1, P2, etc. Technically speaking, up to P99. I'm going to caveat this with, you can also have decimal ones, the 99.9th percentile, the 99.999th percentile, and so forth and so on. Like the kid with the big head. He's the biggest, he's got the girthiest head. So clearly he's in the 99th percentile, but he could be in the 99.9th. Suppose there's 100,000 kids in that population and he's the biggest one. That means he's bigger than 99,999 of them. So he's in the 99.999th percentile. 90,999 over 100,000. Suppose there's 1 million kids in that population. Then he's head girthier than 999,999 of them, which means he's in the 99.9999%. You get the point. There's a lot of nines, but you get the point. You get the point. So these are the integer values of them. The quartiles, there are only 3: Q1, Q2, and Q3, and there really are only 3. There's no Q1.5 or Q2.5. So what I want to do is real quick make sure we understand what we're talking about with these 3 things. Q1, Q2. Let's go. We'll go over here. We'll go over here with this. Give a little more space. So you got Q1, Q2, and Q3. So what I want you guys to do is I want you to think about what these 3 things are. Think about Q1. Q1 wraps up everything from the smallest data point up to the data point, the bottom quarter of the data, essentially. It's the bottom quarter. It's the small. So let's go back to head girth, just as a real example. We're talking about head girth in kids. If you put all the kids in a row from smallest heads to biggest heads, Q1 would be the biggest extreme of the bottom quarter. So what percentile would that be? And I'm giving you the answer by calling it the quarter. It's the 25th percentile. It serves the same purpose as the 25th percentile. So essentially, what it is in words, it's the division between the lower 25% of the data and the upper 75% of the data. So essentially, that's what it is. It's just a marker. So if the 25th percentile for head girth is, hell, I don't know, say 36 centimeters, right? That means that what percent of kids have head girth less than 36 centimeters? If P25 or Q1 is 36 centimeters, what percent of kids have heads that are less girthy than 36? 25%? Right, 75% have more. It goes back to your definition, David. Your definition was perfect. I always thought 80%, 80th percentile means that I'm bigger than 80%. It does. It also means you're smaller than 20%. So basically what this is it's a slide. You have 0 to 100%, 0 to 100, and you're placing marks on that to show where percentages live. That's, again, why it's called relative and not absolute. The average has nothing to do with this. The average has nothing to do with this at all. It's all about how you fare with respect to other members of your data set. What would Q2 be? What do you think, friends? What do you think Q2 would be? 50. That's exactly right. It's the divider between the lowest 50% and the upper 50%. I will tell you this. Hardly anybody calls this Q2. Hardly anybody calls it Q1, very, very common term. Very, very, very. Q3, also very, very common term. Nobody calls it Q2 because we call it what? We call it the median. That's what we call Q2. Almost all the time is the median. Exactly, exactly. So that's the common name for Q2. Nobody uses the phrase Q2. Although I like it when you're learning what a quartile is, it makes sense to have it there. Q1, Q2, Q3. And once we get in, we don't have time to do it today. Once we collect our data today and we analyze, we crunch it on Wednesday, it'll make a lot of sense as to what those dividers are doing with the actual data points. Exactly. So Q3 is going to be the 75th percentile, which is the division between the lower 75% and the upper 25. Those are the quartiles. There's only 3 of them because those 3 divisions divide the data into 4 pieces. Sometimes the government likes to use quintiles. They use quintiles, which would break up data into 5. So you'd have 4 of them breaking up into 20, 20, 20, 20, and 20. Oh, no one's on right there, apologize. Sometimes octals are used, 12.5% at a time to get 8. Deciles, 10, So many, many different divisions are used, but the most popular that I've seen in general are quartiles. Totally. And what I want to do is collect one set of data right now to play with on Thursday with you guys. So you'll need your data sheet. Anybody need one of these? I made some extra copies. Here we go. Here we go. Oh, here we go.
Oh, I have mine.
Do you have yours? Okay. Well, then there we go. So what I want to do real quickly, and I apologize to the residents of Alaska, everybody who was born and raised or spent time in Alaska. This map sucks, but I had to make Alaska scaled down. Alaska's huge. There's a United States map here in the front. Who's playing the home game? Oh my goodness, let's put this back up here. There we go. Playing right here. So right now, figure out how many states you visited. I gave you a map for reference. Define a visit as. If you flew into the airport there, count that. Count that. If you've flown into an airport, chances are you had a layover. Use the bathroom. Let's make this even simpler. If you've used the bathroom in a state, count that as a visit.
All 4 states?
If you've flown, well, that's all we're doing is United States. So count states you've flown into, driven through, used the bathroom in, had dinner in. So, you know, if you flew over a state, don't count that. But if you landed in a state, count that as a visit.
I fight with my wife all the time about airport visits.
You say that
I
again?
fight with my wife all the time about airport visits. It's counting.
As counting? Well,
I say they count, and she says no, they don't.
well, we're going to define it as they do.
Right.
We'll define it here as they do.
I agree.
So we'll get ourselves some data here. Let's shut this down for a moment.